So this question is sliding puzzle. So you're given a 2x3 board, and then you want to basically from the given board, you want to make sure you move the board into this pattern 1, 2, 3, 4, 5, 0, and then you return the list of number of move requires that the state of the board is resolved, and then otherwise you return -1. So they just you know 1, 2, 3. They just explain this pretty quickly. So the one way of doing this is you only want to you only want to move one value in the board. So in this case, I'm moving 0, only 0. You are not allowed to move, two value in the board, at the same time, right? So let's see. So I'm moving 0, right? 0 only, and I only keep the record based on the 0. So in this case, 0 can move up, 0 can move left, 0 can move right. And then what we want to do is we want to get 1, 2, 3, 4, 5, 0. So how do we make sure this is a valid move? It's going to be 1, red color. So this one. So there are 3 possible solutions. So the first solution is going to be if 0 move up, is 1, 2, 3. 1, 0, 3, 4, 2, 5. If 0 move left, 1, 2, 3, 0, 4, 5. If 0 move right, 1, 2, 3, 4, 5, 0. And this is perfectly matched to the target, right? So yeah, we go through the the possible way to do this, and then you'll be able to resolve. So the one trick is when you move up, move left, move right, and if possible, move down. So imagine 0 is right here, you want to move down, right? So if you are moving 4 different direction, so normally we will do is what we will do, 0, 1, and then 0, -1, or 1, 0, or -1, 0. So this is normally what we should do for 4 direction. But in this case, in this example, we're going to just using move left, -1, move right, +1. Move up is going to be what? -3. Move down is 3. So why is -3 when you're moving up? Think about the index. 0 index right here, 0, and then 1 index right here, 2 index right here, 3, 4, and 5. 0, 1, 2, 3, 4, 5, the index. And if you want to move to the top, 4 to 1 is -3, right? If you want to move index 1 to index 4, 1 plus 3 is 4, right? So based on the index, this is a trick, right? Direction is a trick. And then definitely we want to make sure if my current index is right here, 4 index, am I allowed to move in downward? No, because it's out of bound, right? So they are just pretty, the small thing you want to verify before you move. And then let me just go through the sample and then let's just go to the solution and then we'll find out what happened. So the direction is going to be what? -1, 1, -3, 3. Alright, so again, the board can be, the length is going to be 3. Okay, so it's not possible the board is null. Okay, so what I need to store is I will convert whatever this value into the string. But before I do this, I need to just create a linked list, so I will be able to know what's my current string and the next possible state string. So let's do this. So string builder. So I'm traversing the board. Basically, I just append to the string builder. So yeah, and then this will give me 1, 2, 3, 4, 0, 5 in a one single string builder. And then if there's a queue, I'll possibly need a set. so that I don't have to retraverse the same string over and over again. All right, I will explain that later. So starting is going to be string.toString. Start is going to be sp.toString, sorry. And the end is going to be target, right? Target is going to be the 1, 2, 3, 4, 5, 0. Technically, you want to just put it final, but let's see. Final string, something like this. And then I'm going to add whatever the current state of the starting position and into the queue, and which means it's going to be added into the sim as well, so I don't traverse again. And then since the queue is not empty, I will have to traverse. And also I want to keep on track with the current state of the move. So it's going to be result. And if the target is inside the queue, right, then we will return the target right here, right? Else we return -1 outside. Okay, cool. So let's think about how we do it. So I'm going to comment this off first. All right, so I want to measure what's the current size of queue. All right, and I will traverse based on the size of the queue, which means the, look, one single move. So if 1, 2, 3, 4, 0, 5. If one single move, when I say one single move is one single, possible, move for the direction, like this is 3, right? So you only want to traverse, you only want to take 3 elements from the queue. So this is the first 3, right? So if 0 size increment is for loop. Cool. So if the string is going to be queue.poll, if the node we pulled from the queue is match the target, we can return result, right? If not, then you find, right? And then this is how I return a result. So if one single move doesn't match, then you increment your move, right? So when we want to find out the target, sorry, when we want to find out the index for 0, so it's going to be start index. It's going to be the node.index of 0. So we find the value 0 in the board, and we move based on this index. So for in j equal to 0, j less than the direction. Once we find out the 0, we want to move the direction, right? So here's the thing. When we traverse a direction, we want to measure what's the next index, which is going to be the current index, the current position plus the index when we traverse. But it doesn't mean the next index is valid in the board, right? So if only is valid, start index and next index. So how do we know is valid index? So it will be index start, index, next index. So if the next index, which is, if you're at this position, if you're going upward, which is what, -3. If you're going left, is -1. If this is out of bound, then you want to return false, right? Else you want to return true. But we didn't go through all of the scenario. So if the next index is less than 0, or the next index is greater than 5, which is right here, if you want to move right and move downward, you +1 and +3. So it's outer bound, or the star index is equal to 2, and next index I believe is 3. Yes. Then in this case, you are going to return false because 0, let's see. In this case, this is 0 index, 1 index, 2 index, 3 index, 4, 5. So if you want to go from here to here, you plus 3. You go from here to here, you minus 1. And then you are not allowed to go right to reach the index right here. So in this case, starting index is 2, next index is 3, then you will return false. Because if you want to move the cell from here to here, you need to move left, down. You are not to just go right and then teleport to here. This is not allowed. And then vice versa. Which is 3 right here, 2 right here. All right. And that would be it, right? So if this is valid, then we want to make sure we want to swap, right? So later equal to no.toChar_array. And then I want to swap the letters between the start index and the next index. So I want to generate a new string, technically a new string. When we swap, then I want to add into the queue. So char temp equal to string I and string j equal to temp. Once I swap, I want to add into a queue, right? So string next state equal to new string and letters. All right. So if the next state is match the target, I mean eventually, like once this for loop traversal finish, you will poll and then you will find out the node is equal or not, right? But the problem is it possible to break it out earlier if we can find out the next state is already equal the target? If this is true, normally you want to return result, but the problem is you increment this at the end of this, the iteration, and then you are already making a move. So what you need to do is result +1 right here. And the last but not least, if the next state does not in the sim, which we haven't traversed, what you need to do, you want to make sure you add it, right? Sim.contains contains the next state. You want to say sim.add the next state, and also you want to push into the queue. So eventually you will end it. This one single direction move doesn't matter how many possible board you generate. You will end it, and then you'll increment. Where's the increment? Right here. Oh, this is the while loop, right? So this is one single iteration, the big iteration, and then this is one single direction depending on is 0 can move left, upward, right, or downward. And then once this finish, you'll increment the move, and then you'll return, right? So that will be it. Let me run it. Hopefully it's passing. All right, it's pretty challenging for sure. All right, let's see. Let's see like the time and space. Let's look at the space. Space is this, and space. So the space for the worst case is going to be m times m. So n represents the number of row, m represents the number of column. and that's for the space, and then for the time, this is the time, and this is also the time, which is going to be all possible move for the cell, right? So it's going to be the same, m times m. So that will be it, and then yeah, good luck, bye.